Can you hear me? Kindly confirm if you can hear me and see my screen.
Yes, we can.
Thank you very much.
Yes, we can hear you.
Wonderful. So, this is wrong screen. Okay, so we're talking about float type. So, float is a numerical number that has got a decimal precision. That is what we refer to as float in programming, right? And an integer, these are just basically whole numbers. Um, that's what is defined. So with regards to a float, by default, a float comes it's got a precision of about 6 by default, 6 digits after the comma, unlike our normal floats that have got 1. So we can always define the number of decimal places to be kept. We'll cover that when we do arithmetic operations, to say, okay, maybe we are dealing with money where we know money is accurate to 2 decimal places. How do you always ensure that your float type retains uh, the decimal point precision? Okay, that was as far as the float number is concerned. Now we're looking into complex numbers. For example, I can say a is equal to one, maybe 3 plus 5j. We know by the very inclusion of this character, I know in mathematics square root of 1 is I, but in computing terms we use j and not the I that is mathematically acceptable as the square root of 1. So in computing, the square root of -1 becomes j. So anything that has got an imaginary part we have to include j, right? The moment we do that, and we evaluate our a, you realize it's already telling us that a is a complex number, right? And you realize I'm using these data types without explicitly importing any specific class before I can run an instance of the class. Why is this so? This is so because the data types that I'm working with, they are primitive data types. We spoke about primitive data types yesterday. I'm just trying to find, yeah, right? So you don't have to explicitly call them or import anything before using them. They are already known by Python. They are like default data types that you find in Python that come pre-installed with Python. So you don't have to code them like what we do with classes, right? I'll explain this a little further when we deal with with classes. Okay. Then apart from numeric data types, we've got what we call collections, right? And collections come in different formats. We've got what we call lists, These are Python collections of data The data collected in lists does not necessarily need to be of one data type. Right? What do we mean? How do we know that this is a list? So a list uses square brackets. So every time when you create a collection using square brackets, you're basically creating a list, right? So number one, creating an empty list. We can say ls is equal to, the moment I do this, I've already created what? A list. The only thing that's happening with my list is it's what? It's an empty list. It doesn't have any contents yet. You see, it's telling us that it's type of class list. Why is it type of class list? Is because we've used what? The square brackets. But we can also explicitly create a list that is populated, that has got elements already. Okay, I've populated my list. Sorry, my bad. I forgot to. So we can see that this is a type list, but one thing that I want to emphasize, this we know it's a string, this we know it's an integer, this we know it's a string again, this we know it's a boolean, this we know it's a what? It's a list. But all of these are contained within a list. So that's what I was saying, to say a list can also contain data types of what? Uh, different data types, elements of different data types. Right. So in a list, you don't necessarily have to put, to say if you've got numbers, you're just putting numbers throughout. You can have it as a collection of many different elements of different data types. Um, we'll look into the manipulations and functions that we can perform on lists. Right. Let's move on to what are known as tuples. So just like lists again, tuples are what? Collection. They are collections. So which means they can take come on. Sorry, my laptop is not as responsive as I would want it to be. Maybe neta nekushanda for the past 2 days. So a collection is where we can pretty much get we can put numerous number of elements all at once. So it's like we are collecting things. The only difference between a tuple and a list is a tuple uses the normal parentheses or the round braces, right? Round braces. Right. Aya ma-brackets aya ndo ma-parentheses anoshandiswa netuple. Then the other thing, a tuple, unlike a list, is immutable, right? Which means once created cannot be changed. So in other words, it's a read-only memory. Right? So once you create it, you can only simply read from it. You cannot make much manipulations in terms of changes, right? Which means by that lists are mutable. Right? Why do we need tuples then if you really cannot change them? Is there anyone who can think of a reason why we need tuples? Or use cases for tuples?
Hello?
Yes, you can go ahead.
Maybe I can try.
Yes, please go ahead.
Okay, maybe they are used to store sensitive data that should not need to be altered by maybe a group of individuals or certain programs. I don't know.
Yeah, that's absolutely correct. Courage. Um, Information that you want, that you do not wish to be edited, right? You rather put it not in form of a tuple, so that the person, whoever is going to be accessing and using that information, what they can only do is read and read only, right? That is the use case of tuples. So like I've said, a tuple is created, right, through use of what? Of these parentheses, right? And this is but now the question is, this in programming really doesn't make sense, right? To create a tuple like this, right? Why does it not make sense? Yes, it's possible, but logically it does not make sense. Why? Because you can no longer manipulate this, right? You've just created an empty tuple. Then the question is, what's there to read? Because after creation you can't manipulate it, right? But it's something that is possible in Python. And just like list as well, you can then create a list that a tuple that has got contents, or a populated tuple, right? Where you can then assign, again, like just like lists. Let me just copy the same elements that I've put in the list. Right. If we evaluate again, we see it's a tuple, right? And it can collect varied data types, including list and tuple. So let me also add a tuple here, where right. So it can include tuples and any other data type as well. So you've got a list within a tuple, and you've got a tuple within a tuple. You can also add other data types that we haven't spoken about, right? That's all about tuples. We've got what we call sets, right?
Sorry. Pamatuples are. You're saying they are immutable, and it. Maybe because there's an example that I saw in my lecture notes. This where they were altering something about matuples. Because let's say you have created your tuple with information that you do not want to be altered by any other person, right? But then there comes a situation where you need to alter that particular information because you know how it is with the information he cannot be cast in
Static.
stone.
Yeah.
How maybe if you explain more on the impermeability with my example so that we fully grasp it. Um, what does it? It's not really exactly because to me it wasn't clear. Someone else trouble.
Okay. Thank you very much for asking such a brilliant question. Now, once a tuple is created, the fact is it cannot be changed. However, it does not mean that your program or the model that you are running cannot take any other tuple in place of the tuple already created. So remember when we spoke initially, where was it? Something that I think I then said it as an afterthought. If I didn't explicitly mention it, to say Python overrides variables. Did I mention something like that? If you reuse the same variable name as was initially used, it will override the previous variable created. Oh yeah, I think I was used. Yes, I think it should be here. I think when I then did d is equal to 12, then d is equal to true, right? So that we know about what? About variables, right? So I created my variable tp, right? I cannot come and change tp directly to say I want just to remove this, right? The only option that I can do is to come and say TP is now equal to a new tuple altogether, right? A new tuple without what? Without this element, right? If I do it so, I would have updated the tuple, but I've not necessarily changed the contents uh, directly. How do I mean? Let me show you an example. This list that I've created ls, right? If I come and say ls here to call it, I see there are these elements. Then I say to myself, no, man. I need to delete teacher one. I can come and say ls dot pop in this case. Yeah, I'll just use pop. No, pop 0, right? I want to remove teacher one, right? Then after that, I want to print ls. Do you see what has happened? Teacher one has been removed through a manipulation of the list. This is the mutability of a list. I can change contents without directly or explicitly to say, in that list that I've created, just go and remove something that is at position 0, right? But in the case of a tuple, without me updating and creating a new tuple, I cannot then come and just directly, like what we've done up there, remove an element within a tuple. So TP, we see it's got this as the elements. Let me try now what I did on top. Say pop 0, right? It gives me an error. Tuple is no object or attribute pop. Okay, let me see, because I want to remove something. Let me see options that I can do. There are only two things I can only count and index, right? So which means it doesn't have any other method that right, that specifically changes its state. Let me try. There is a method called remove, right, and see if it removes. Again, it gives me an error. But if I go to the list, I can actually go and remove a certain element without declaring a new list altogether. I don't know if I've been able to clarify.
Yeah. I've picked it.
Great. And please, I so much encourage you to do so. There are certain things that probably may just slip my mind, like the way I'd already overlooked getting into the examples. So when you ask questions and interact, you also tap into the tacit knowledge. Sorry, is there anyone speaking?
Yeah, I was trying to run my first tuple. It's giving me an error.
It's giving you an error. That's all right. Just a moment. Let me stop sharing. Are you able to share your screen? Okay.
Have you seen it?
Can you bring the note? Can you click on the notebook? Oh yes. Now I can see it.
Yeah.
Yeah, the error means string object is not callable. Okay. After, is there anyone who wants to try and assist him to debug? Hmm? Anyone willing to try? Okay. If there is no volunteer, TP is equal to empty tuple print str, then in brackets TP plus is of type plus str, then that, then str object not callable. Okay. Uh, before this, have you been able to call the string object?
Yeah, I've tried it here, but it was refusing. Yeah.
It was also refusing.
It was giving me this. Yeah, it was giving me these errors.
Okay, on that one, it's you go and put str before a.
Yeah. And then I put bracket.
Open bracket, then close bracket after a. Can you run? Yes, I thought as much as well. What version are you on? Version of Python?
I
Just
think
press.
it's the one that.
Hmm? Sorry, you were
Can you come
saying?
again? I think it's the one. I don't know if it's the one that you said I need to degrade it when I'm
All
doing
right.
something.
Yeah, I thought as much, because as they also upgrade the versions, there are certain things that they change, and they may remove or add new features. So it depends. So in your case, what you do, instead of trying to do explicit type conversion, I want you to go and remove the str.
On the first one.
Yeah.
Yeah.
Yes. And remove the brackets again that close encompassing a.
This one.
Remove the closing bracket after a. At the first a, remove the closing
This one.
bracket. Remove the closing bracket. The closing.
Okay, this one. Okay.
Yes. Then you remove the plus sign and replace it with a comma. Then you remove the other plus sign and replace it with a comma. Then you remove the opening bracket at type and also remove str. Right. Can you try to run? Okay. Can you go to kernel? Restart and run all. So restart and clear output. Restart and clear output. Okay, you can run the first that one that we.
This one.
You can try to run it again.
Yeah, it's now.
You can try to run the one that was giving you problems again.
Yeah. I'm now there.
It's all right.
Yeah, thank you.
Welcome. Is there anyone who's got a question or who's facing challenges? Can you see my screen? Can you all see the screen now?
Yes, we can.
Yeah, we can see it.
All right. So if there are no questions, we'll move on to sets. So sets, I think I don't need to labor much on what they are. We've done sets in mathematics, so these are the same sets that we are talking about here, right? The only thing that we may need to know is with sets, they do not accept duplicates, right? And they order elements. So these are the key points to remember about sets. Then lastly, this one will be a bit tricky, but I hope you understand it. They are denoted by round braces or parentheses. Sorry, Kelly, rather. Sorry, not round braces. Kelly braces or parentheses. Then an empty set is created using round braces. Right. What do we mean that they do not take duplicates? Who see about that? So unlike tuple, these they are mutable. We now understand what mutability is all about. What else about sets? I think these are the 5 points to remember about sets. So I'll start with the fourth one, which says an empty set is created using round braces. Right. Remember, round braces, we said they create tuples, right? If you remember what we just discussed here, we created a tuple using round braces. So how then can we create sets using round braces? The only thing is that what we do is we then also explicitly define that it has to be a set. So st is equal to set like this. It creates an empty set. You see, it then creates it as an empty set, right? But if you want to create a populated set or a set that has got elements within it, you then have to make use of what? Of curly brackets. So we're going to say st is equal to curly brackets 2 6 3 7 9 1 8 sorry, yeah, 6, that's all right, 8 2, right? Now I want to demonstrate number one, the first point, to say that it does not hold duplicates. They do not allow duplicates. And also that they order elements, right? The default ordering is in ascending order. Right? And that they are denoted by curly brackets. So the first three, that's what we are demonstrating. So I'll run this and then I'll call again st. You see what has happened? Regardless of me having put double true as well as double 6 within the set, here it just returns to me one of the elements. It does not return the true, right? And it then sorts this in ascending order. So the minimum or the least number is 1. So it then puts that as the first element of the set. Do we see that?
Yes.
Great. So let's always remember that that's how sets actually work. So it is still telling that it is a class set, right? Again, it is mutable, so which means you can manipulate whatever is in there, right? The other thing, I think with sets, we can do multiplication with a scalar. This is now pure mathematics. Right? So I can come and say 3 times st. Is that right? Sorry, what's happening? Can you multiply this? Oh, sorry, I'm thinking of matrices. Sorry, my bad. Their matrices will cover matrices on their own. Right, my bad on that. Is there anything else that I can talk about sets? I think this is the basics of sets. Yeah. So areas where you would use sets are probably when you're doing student registration, where you don't want to have duplicates for students, to create duplicate records, right? So a student has to just have one record in the database. We don't have to have multiple records of the same student, right? That's one area where sets may be applicable. Which other areas can we use sets? I also can't think of anything anymore, but let's move on. What then? From here we've got another data type that we call dictionary. Sorry, wrong spelling. Again, like sets, a dictionary uses curly brackets, right? But unlike a set, a dictionary, it has a key and value pair, right? So a dictionary, when you are populating it, this one is turned to a default set because it does not hold this quality of key and value pair. But see, the moment you then put the key and value pair, it would be regarded as what? As a dictionary and no longer a set. It is mutable. Extraction of value is done by key element. What else? It is denoted by keyword dict. Allow me to go back. I'm just also realizing I've been forgetting to mention this. It is denoted by keyword set. It is denoted by keyword tuple. It is denoted keyword list, right? So let's go ahead and create a dictionary. So creating an empty dictionary, simply you just use curly brackets so we can see that it is a dictionary, and we can also create a populated dictionary that also holds data of different data types, including a dictionary as well. Okay, on this one I have to create it. So to separate the key and value pair, we use a semicolon. So you see, we've created what? A dictionary. So I was saying extraction of value is through a key element. So if I come and say dt name, right, it gives me this value assigned to the key name. So this is how I get the value. I have to call the key, right? If I say dt address, you realize again it gives me all this, right? Of which this is again a dictionary inside what? Another dictionary, right? If I want probably just only the house number, I can come and then put another key of the inner dictionary. Okay, let me put it on the next cell, so that we can also appreciate where this is coming from and how it's developing. If I just want the house number only, I'll then have to go into the inner. So the first time I access the key that directs me to the dictionary, then within that dictionary I then specify again another key. Now I can only get 31. Are we following?
Yes, we are. So it means you can put my names and my age ndichichi akawanda in this dictionary.
Certainly.
Okay, maybe if we can show us how you can add more, because yeah, more lines.
Okay. Okay, I'll create a simple dictionary for usernames and passwords. Okay. Right, so I've got 1, 2, 3, 4, 5, 6. Right. Then I create username. Okay. Let me make it simple. Login equals this, right? And this carries this. Then I say comma, enter, uname carries that. T-Rex sign, teachers 013, teacher 013H, just a moment. Teacher 013H, one, two, three, four. Sorry. Right. Tadona list ready. Dictionary ready.
Yes.
Yeah, Tarona.
So this is how you probably implement it, right? Such that can uchida access a password. Yeah, teacher 013 for example. You then come and say login in brackets username 2, then comma, is that and zviri kubatika.
Yeah, very clear.
Asika tichazo kumberi mberi kuti tichadzika like what exactly did I do here and what implement. It will probably create like a login page where someone has to type in their username and password ichinda ichinosearcha in a dictionary and so forth and so forth. But for now we just want to have the high level overview. Hello?
So I have a question. Why did we use the square brackets apart from Soroko? But mighty so you just scroll up a bit. Yeah, EPUB. Why did we use the square brackets? Address and house number.
Address and house number.
Yes.
Okay. Is there anyone who would want to try and assist? Come on, good people. There is no right or wrong answer. Okay. you can you can nominate courage kuti udaunza voice rani. Okay, maybe for now I'll make it easy for them. Pamwe achiri kudigesta achifunga answer. So what I'm saying is there anyone who wants to try? Okay. What I'm saying here is what I was demonstrating rather is the fact that all these data types that we are talking about, remember I'm always using the word collection, right? They are called collections, which means they collect numerous data elements all at once. That is one thing. Then the second thing that I then mentioned is the data elements that are then collected or contained within these collections. They can be of varied data types. So here I was just illustrating to you to say you can have all strings on the key and value pair. Here I've got a string and a numeric number. But here I've got a key and another dictionary within a dictionary. I was seeing the concept that I was exploring.
Yes.
Yes. So here I'm also just telling you to say it can contain another data type. And which data type is this?
List.
Yes. So I've also included a list within what? Within a dictionary. And that list is referenced by this keyword password. Why did I include a list? Because I'm saying under passwords, I can have passwords of so many different people, right? So I would need another collection instrument that will be able to collect all the passwords that can be thought of in this world, right? And it does not necessarily need to have only one data type as I've done here to make it strings. I can even do it this way, where probably this is a pin, right? So, but the important thing that I'm pushing across is whatever this other collection tool is it's referenced by a key, which in this case is password, right? Are we getting that? I don't know if I'm able to clarify. So I could have also, we can just do it. I could have used a tuple, right? Like what we're discussing. And not necessarily a list, right? Still, I'm still able to get the same results. Or on one I can have a tuple, and on the other I can have a set, right? Like this. Oh, sorry, one thing that then happens with a set. Sorry, just a moment. Hi, Mishek. Ndiri boso anaukanga mando sanotumira malogins. I'll be with you shortly. All right. Okay, the only thing with my set here is, remember things that I've spoke about the set, to say it would want to reorder and remove my duplicates, but because these are string values, the ordering is not that straightforward, so to say, right? But I can have this not probably as a list, right? So it's up to you, really, what you want to do and how you want to achieve this. Is there any other question, or have I done justice to your question?
Yes, it's now clear.
That's great. Right. This data type, we'll talk about it when we start to also cover issues to do with functions and manipulations that you can do on data. So I've deliberately left out strings and I've put it under arithmetic operations, right? So that at least when we cover strings, we then start looking at the things that I was then saying. The moment you know the data type that you're dealing with, you then know the kind of manipulations that you can make on that data type. So we are going to be talking about that when we visit strings. So for now, we'll skip the strings data type. Is that okay?
Yes.
It's okay.
All right. So under arithmetic operations, basically, uh, these are operations that allow us to carry out mathematical calculations and right. There are 7 arithmetic operators in Python, and these are plus, addition operator denoted by a plus sign, then we've got subtraction denoted by hyphen, um, we've we've got multiplication operator denoted by an asterisk, right? Then we've got division operator denoted by a forward slash, right? Did I say 7?
Yes.
There should be 6. Modulo operator denoted by percentage. Then lastly, I'm forgetting the name assigned to it, but I'll give it to you once I recall it. But this is where we use a double division sign. Yes. No. In fact, let me do this and talk about operators in general. These are special characters that instruct the compiler to perform specific tasks and manipulations on data, right? And that basically there are 3 main types of operators. Namely, arithmetic, logical, and logical name, conditional operators. So these are the 3 types of operators that you will find. There are more operators that we are going to be talking about, but these are the 3 main categories or main types that you meet in programming. All right. Huh? All right. Sorry for that. Arithmetic operators, like what we are talking about, these they perform mathematical manipulations on data, right? All mathematical computations they are made possible because of these operators. So we can have we can do things like addition, we can do 2 plus 2, right? Subtraction, right, where we can do 9 minus 15, right? We can do multiplication. Under multiplication, we can do something like 15 times 258, right? Division, okay. 300 divided by 2. So you realize with all these other arithmetic operators, we pretty much maintain the data type of what things that have been added. So if I add floats, I get floats. If I add integers, I get integers. If I add complex numbers, I also get complex numbers likewise. Only in rare cases, if I mix the data types, it will give me the more precise data type. So you find in terms of integers and floats, the float is more precise because it has got decimal accuracy, so it automatically converts it to what as such. Again, 9.0 minus 15.0 and comma 9 minus 15.0. We literally still see the same thing happening. Comma 15.0 times 258.0, comma 15 multiplied by 258.0. It pretty much follows the same thing, but with division, default resultant data type is float. Can anyone tell me why it defaults to a float?
I think maybe it's because with division, sometimes you might have a remainder.
Thank you. So it takes it already provisions for what? For decimal accuracy, because if you divide integers, you are not guaranteed to always get integers. 7 divided by 2 comes with some decimal accuracy, so by default it already takes a float. So if you really want it to be an integer, you then have to consider things like type conversion or typecasting, what we spoke about yesterday. Or alternatively, that's where you can then I've really forgotten the technical term, but this is where you then can come and choose a double what? A double division, right? Where you're saying I want the integer part. In this case, it will give you 1/5, right? However, you have to note that the double division discards the remainder. What do I mean by that? So if I say 7 divided by 2, under normal circumstance, this should be 3.5, right? But when I do this, it will give me only 3. Why? Because it then throws away the remainder. Do we get that? Tichiri tese.
Yes.
Yeah, tichiri engine zakubhoira
Yeah.
that tichitese.
All right, it's okay. We had started now 7, so I just wanted to get to 9. I don't know if it's okay with you if we can just stretch to 9.
It's okay.
It's okay.
This is the last part that we are covering anyway. Okay. Then the modulo function, what it allows us to do. Yes.
Let's say I want to have the results for single division and the double division on the same line. How do I do that? Like, kuti ndoda kucompare of some sort, kuti you were on the left and the other one you were on the right, like what we were doing for multiplication and addition.
You do the same thing I've already done on the screen.
I'm just getting one result for the last one.
You separate them by a comma. Check what I've done here.
Right, it's okay, thank you.
Okay. Okay. The modulo sign, what it does, it evaluates a division and then returns the remainder as the answer. Right? What do I mean by that? If we say 7 modulo 2, the answer that we will get is 1. It's basically telling us that 7 divided by 2 will get a remainder of 1. And 8 divided by 2 will give us a remainder of 0. Right? Then the question is, where in real life applications can we apply the modulo and the double division functions? Anyone to try?
So what was your question again?
I was saying we've covered the double division, right? Where we're saying it gives us the integer part of a division result. Then the modulo, we said it evaluates and gives us the remainder. So I'm saying, where in real life can we apply these? The multiplication, the normal division, the addition and subtraction, we know where we use those. But the double division and modulo procedures, where would you want to use that?
Or maybe if you want to identify if a number is an odd number or even number.
Thank you. So such cases, you then definitely need to use one of these, right? Um, there are times when you do maybe certain calculations like that involve yeah, like maybe you want to make a division of people to be in a group, right? There's no way you can have 3.5 people in each group, right? So it will then definitely tell you to say one of the groups will have 3 people, then the other one will have um, 3 plus the remainder. So when you're actually writing your code, you write it in such a way that you evaluate the integer um, results as well as the remainder and see how you can then apportion that. I don't know if we also uh, get that example.
Yes, we do.
That's all right.
Can you come again?
Okay, I was saying to you, suppose you want to divide um, maybe from a population of people, you want to divide them into a certain number of groups, right? There is no way when you've got a population of 7 and you want to divide them into 2 groups, we are going to say each group is going to have 3.5 people, right? And remember, you are writing your code and to divide people. So the logic of working with people should then guide you to say there is no way I can get a float precision for people. They are always counted in integers. So dividing into 2 groups, which means there's one group that's going to have 3 people and the other one that's going to have 4 people. So how can you go about making the coding of that? So this is where you would use a double precision. And then the remainder of the evaluation, you add it to one of the groups. I don't know if that example is now clear.
It's clear, very clear.
All right, that's all right. Um, I don't know. This will be the last part of our today's lecture. And Banana 7. Sorry, there are 6. These are the only mathematical. Ouch. I don't know if there's anyone who's got any questions on the things that we have covered today. Or
Yeah, once you send the link with the recorded lecture, we'll also be able to just follow through and then practice it.
great, great. I'll also be sharing with you the notebook for your own revisions. And please do feel free to engage in case you need help. My WhatsApp, my voice call, my email, they are all open. All right. That being said, good night, everyone. We'll touch base tomorrow, where we begin with our weekday sessions.
Tomorrow you said we are covering which sections?
Tomorrow we are starting from Python strings. Then we get into string manipulation.
Okay.
Yes. So I haven't really forgotten about the other part that we wanted to speak about initially, but it's the same thing, the same strategy that you are following. where we remember we said to ourselves we're going to be covering variables, data types, and where did I write it?
It's okay.
Alright, so tomorrow we'll definitely cover strings and string manipulation. Then from there, teta kudzoka kuma operators, then takunyora macodes. So this is the last part of the things that we're supposed to be covering. All right, good people. I'll pause the recording and end the lecture.
Thank you.
Thank you. Have a great night.
Thank you.
Right, thanks.
Thank you.